Imagine arriving at work to discover that every server in your data center has been locked by ransomware. Applications are offline, emails are dead, and revenue is evaporating by the minute. In the server room, an engineer is scrambling to find a technical patch. Up in the boardroom, the CEO is watching millions of dollars bleed from the balance sheet. In that exact moment, the only question that matters is, how quickly can we recover? Answering that question requires two distinct disciplines. Disaster recovery, or DR, is the specific tactical process of restoring IT infrastructure, applications, and data after a disruptive event. It focuses entirely on bringing the technology back online. Business continuity, on the other hand, keeps the business operating. While disaster recovery rebuilds the servers, business continuity might involve moving your staff to a temporary building so they can continue working during the outage. For cybersecurity professionals studying for the CISSP exam, there is a common trap: treating disaster recovery as a purely engineering problem. If your immediate instinct is to choose the most advanced technical fix or the fastest backup server, you risk building a strategy that fails the organization's actual needs. Mastering disaster recovery means stepping away from the pure IT mindset. Every technical choice you make must be evaluated through the strict lens of business survival. To see how that business lens works in practice, we look at the formal disaster recovery lifecycle. It is a highly structured pipeline, not a chaotic IT scramble. This pipeline shows the 5 phases of disaster recovery. Phase 1 is the disaster declaration. A single server crashing is a local outage. It requires a formal business decision to activate the disaster recovery plan. Phase 2 is the damage assessment. Teams evaluate exactly which systems are affected and what data is impacted to determine the total business impact. Only after the damage is quantified do we reach Phase 3, recovery activation. This is where technical teams execute predefined plans, falling back to alternate sites or restoring from backups. Phase 4 is system restoration. Rather than bringing everything online at once, systems are rebuilt in a strict order based entirely on their criticality to organizational operations. Finally, Phase 5, return to normal operations. Stabilized systems transition away from the emergency state and back to standard business processes. The structure of this lifecycle confirms that business impact analysis dictates every technical action that follows. Let's look closer at Phase 3, the point where alternate recovery sites are activated. Selecting the right alternate facility is a mathematical calculation. This graph plots recovery speed on the x-axis against cost on the y-axis, illustrating the tension between how fast you need to recover and how much capital you are willing to spend. Down in the bottom left is a cold site. This is a facility that provides basic physical space, power, and network connectivity, but contains no active hardware. Because it's essentially an empty room, a cold site is the cheapest option available. The trade-off is time. You must purchase, ship, and configure all new hardware, resulting in the longest possible downtime. Moving up the curve, we find the warm site. This facility contains pre-installed equipment and live network links, though it still requires your team to configure systems and load backup data before use. It is a compromise. It brings systems online faster than a cold site, without demanding the extreme budget of a fully active duplicate. Finally, in the top right quadrant, we have the hot site. This is a fully operational duplicate environment, receiving real-time data replication and ready for immediate failover. A hot site provides the fastest possible recovery. However, the cost of maintaining a second, constantly running data center is massive. It is viable only for critical systems, where even a few hours of downtime would bankrupt the organization. The optimal choice is not automatically the fastest one. The correct recovery site is the one that perfectly balances the cost of the facility against the financial penalty of the business's downtime. Alternate facilities are useless if you don't have the data to populate them. Your backup strategy is the technical foundation of the entire recovery plan. A full backup is a complete copy of all your data. While it is comprehensive, executing it takes a significant amount of time and demands massive storage capacity. To save time and space, organizations use an incremental backup. This copies only the specific data that has changed since the very last backup of any kind, creating a sequential chain of small files. The downside is the restore process. To get your system running again, you must restore the original full backup and then apply every single incremental chain in exact sequential order. If one link in the chain is corrupted, the recovery fails. A differential backup offers a middle ground. It copies all data that has changed since the last full backup. While daily files are larger than incrementals, you only need 2 files to restore the system, the original full backup and the most recent differential. But building these backup architectures and signing leases for alternate sites is meaningless if the plan has never been proven to work. A plan must be rigorously validated. This starts with checklist reviews and walkthrough discussions, then practicing realistic simulations, and finally full interruption testing, where systems are actually taken offline. Your mathematical backup strategies dictate your exact recovery window, and rigorous testing is the only way to expose the flaws in those calculations before a real disaster strikes. All of this brings us back to the core challenge of the CISSP exam and the specific strategic mindset required to pass it. When you are presented with a disaster recovery scenario on the test, you must actively resist the urge to select the most advanced technical fix. Instead, process the scenario through the CISSP evaluation filter. The disaster event drops in. Layer 1. Assess business impact and calculate financial damage. Layer 2. Prioritize and rebuild the most critical systems first. Layer 3. Align recovery with the enterprise's budget and strategic goals. The alternate sites, the backup chains, and the testing methodologies we discussed are not the solution themselves. They are technical variables you plug into this business equation. A catastrophic failure is inevitable, but ultimate survival isn't determined by having the fastest servers. It is dictated solely by how deeply your recovery architecture is perfectly aligned with the business it protects.